Lane, and let's enhance your grasp in math inefficiency, transportation assignment problem. Now, we will discuss a transportation problem. Weezing needs to deliver 80,000, 70,000, and 90,000 magic supplies into the Magic Academy, the castle, and the village, respectively. He has two magic towers where he could get 110,000 and 130,000 supplies from, respectively. With the given unit cost data, how could Wizzy ship the magic supplies to minimize the magic power he would use? First, we will apply the northwest corner rule. So, you will first create a table. As given, there is a demand of 80,000 magic supplies in the Magic Academy, 70,000 of magic supplies in the castle, and 90,000 of magic supplies in the village. Next, there is 110,000 supplies in the first magic tower and 130,000 supply in the second magic tower. Now, we have our initial table, thus, we will apply the northwest corner rule. According to the rule, you select the upper left cell or the northwest corner cell of the transportation matrix and assign the minimum value of supply or demand. As we can see, 80,000 is smaller than 110,000, so we put 80,000 to that cell and subtract 80,000 from the supply and the demand. We move on to the next cell, T1C, right to T1A. We cannot go to T2A since A or the Academy already got their 80,000 demand from Tower 1. We, once again, get the minimum value of supply or demand. In this case, it is 30,000. So we put 30,000 to the cell and subtract 30,000 from the supply and the demand. Since the castle still has 40,000 remaining demand, we move on to Tower 2. Get the minimum, which is 40,000, then subtract 40,000 from the supply and the demand. Since the supply from Tower 1 is already exhausted, we move on to Tower 2. Get the minimum, or what is left, in this case, 90,000, and subtract 90,000 from the supply and the demand. Now, we have our first transportation assignment matrix. Before moving on, we need to double check if all is balanced. Add the rows, and the sum should be the supply. We can see that both Tower 1 and Tower 2 are correct. Let's move on to the columns. The sum should be the demand from the academy, castle, and the village. So let's see the total magic cost by multiplying the assigned transportation supplies and their cost and adding them all up. We will have 9.3 million magic cost. However, how would we know if it is the most efficient way of transporting the magic supplies? We will use the stepping stone method. Here, we will select the unoccupied cells. First, we will test T1V. We will find the closed path where we will turn at cells which are occupied. Then, we will assign alternating positive and negative signs to the unit cost, where it starts with positive for the unoccupied cell. The path for T1V would be T1V to T2V, T2C to T1C. Now, with the assigned signs, we get the sum of the path unit costs. As seen below, it is negative 10. So, what does it mean? It means that the transportation assignment is not efficient. You need a zero or a positive number to tell that that path is efficient. The next step after evaluating the unoccupied cell would be to get the minimum number in the negative sign unit cost. In this case, the negative sign unit cost was 30,000 and 90,000. And we would choose 30,000 since it is a smaller number than 90,000. Next, we will add 30,000 to all positive sign unit costs and subtract from all negative sign unit costs. This will now be the new transportation assignment. We will check again the unoccupied cells whether that transportation assignment is efficient. We will start with T1C. Shown in the screen is the closed path for T1C, and its evaluation is 10, which means that this path is efficient. Next step is evaluating the succeeding unoccupied cell, T2A. As we can see, we skipped T1C since it is an unoccupied cell, and we cannot turn at an unoccupied cell, only in the occupied cells. We also skipped T2C because we do not need to turn since the direction would be straight at T2A, the unoccupied cell. Adding T2C would also disrupt the unit cost sign assignments. The unoccupied cell should start and end with a positive sign. So as we can see, the evaluation of T2A is 20, which means that this path is efficient. Since we evaluated that the unoccupied cells are effective, we have our optimized transportation matrix. We multiply the unit cost of the transportation assignments and add them all up. Now, we have our total magic cost of 9 million. Let's tell Wizzy this transportation matrix to help him minimize his magic power cost.